Alright, so now we are going to discuss the concept of definite integrals. Previously we were doing indefinite integrals in which you weren't given the limits and you were adding a constant of integration. Now whenever you are being asked to integrate a function with respect to x, let's say, so there are going to be limits on this integral sign. This one is going to be the lower limit and this one is going to be the upper limit. Once you have integrated the function, then you are going to apply the limits.
Oh,
Okay, so I'm going to show you an example. For example, you have a function f of x as x squared. So if you are asked to integrate x squared from 0 to 5, that this is how you are going to solve this. You are going to first integrate the function, and integration of x squared is going to be x cube upon 3, and then as a last step you are going to apply the limits. So this tells you that you have integrated the function and the upper limit is 5 and the lower limit is 0. You are going to substitute the upper limit first. So that is going to be 5 cube upon 3 minus then the lower limit. So 0 cube upon 3. This is 0. So answer of 5 cube upon 3 is going to be 125 upon 3. So you integrate the function and then apply the limits.
okay.
Okay.
Yeah.
So let's try these examples. The first part says integration of x squared plus 5 upon x to the power 5 plus 3 upon x squared dx. So in order to integrate this function, the first step that comes to my mind is split the fraction. So it's going to be x to the power 5 upon x squared plus 3 upon x squared. And then you can simplify this further. You are going to get x cube plus 3x to the power of minus 2 dx. You are required to integrate this function from 1 to 2. The integration of x cube is going to be x to the power of 4 upon 3, and integration of 3x to the power of minus 2 is going to be 3x to the power of minus 1 over minus 1. And then you are going to remove the integral sign and write the upper limit over here and the lower limit here. Before plugging in the limits, it's advisable that you simplify the inside bracket. So that's going to be minus 3 upon x. Now if you plug in the upper limit as 2, you get 2 to the power of 4 upon 3 minus 3 upon 2 minus, then you are going to plug in the lower limit, that is 1. So 1 to the power of 4 upon 3 minus 3 upon 1. If you simplify this, you should get 5 over 2 minus 11 over 4, and the final answer is going to be 21 upon 4. Is the working understandable?
Yeah, sir.
Okay. Now I want you to try the next one on your own.
Okay.
Okay, so for the second part, uh, we are going to first write our function as 3x plus 1 to the power of half, and then integrate this bracket. So that is going to be 3x plus 1 to the power of 3 upon 2 divided by 3 upon 2, and you're going to apply the limits 5 0. So if you simplify this further, you're going to get 2 upon 3 times 3x plus 1 to the power of 3 upon 2. Limits are 5 0. When you plug in 5
Sir,
times 3 is, yeah,
for the denominator, don't you have to multiply it by the differentiation of the bracket?
yeah, very good. So we are going to multiply this by 3. Multiply this by 3. Okay. So then you're going to apply the upper limit first. So 16 to the power of 3 upon 2 is 64 times 2 divided by 9. That's 128 upon 9. And when you are going to plug in 0, over here you're going to get 2 upon 9. So yes, the answer is 14.
Okay.
Now you can try the next one. 10 over 3 minus 2x the whole thing squared. So as a first step, you can take 3 minus 2x to the power of minus 2 in the numerator, and then you can pull out 10 outside the integral sign. Then you can integrate this. So 3 minus 2x to the power of minus 2 plus 1 divided by the new power, that is going to be minus 1 times minus 2, and the upper limit is 1 and the lower limit is minus 1. So this is going to be that if you solve the denominator first, minus 1 times minus 2 is just 2, and 3 minus 2x to the power of 1. Now when you plug in 1, you get 2, 1 upon 2 minus, and when you plug in minus 1, you get 1 upon 10. 10 times 1 upon 2 is 5. 10 times 1 upon 10 is 1. So you should be getting 4.
Okay.
Alright?
Yes, sir.
Should I move on?
Yes, sir. You can move on.
Okay. Evaluate 4e to the power of 2x minus 3, the integral of this function with respect to x. So I can show you the working. First of all, you can pull out 4 out of the integral sign. Then to integrate this function, you know what is the integration of e to the power of 2x minus 3? It is going to be the same, e to the power of 2x minus 3 divided by the differentiation of the power. And instead of writing plus c, you can just write down the limits because it's a definite integral.
Okay.
Now you're going to first plug in 2. So e to the power of 4 minus 3, that is 1 over 2 minus e to the power, then you're going to plug in the lower limit, e to the power of minus 1 upon 2. So this comes out to be, the denominator is same, so the denominator is 2. This is e minus 1 upon 2e. I can pull out 2 outside, so it's going to be e minus 1 upon e. So the final answer is 2 times e minus 1 upon e.
Okay.
Okay, try the next one, please. So integration of 3 cos 2x is simply going to be 3 sine 2x upon 2, and integration of 5 is going to be 5x, pi upon 4 0. We are going to plug in pi upon 4. Okay, this is the answer for the upper limit minus the answer for the lower limit. It's going to be 3 sine 0 upon 2 plus 5 times 0. Sine 0 is 0, so this everything is going to be 0. 2 times 1, 2 times 2. Sine pi upon 2 is 1 minus 5 pi by 4. So as an exact answer, you should get 6 plus 5 pi upon 4.
Sir, how did you get one in the
Uh,
step before?
Sine pi by 2 is 1.
Oh, okay.
Were you getting the same answer in decimal?
Almost.
I believe this was plus 6 plus 5.
No, in decimal mine was coming to 3. I probably made a mistake somewhere.
Okay. Have you copied down the work? Should I move on?
Yeah, sure, you can.
Okay, now whenever you have uh, these kinds of function, for example 1 upon x, we discussed this that the integration of such function is equal to ln of the denominator, that is ln x plus c. And when we had bracket 1 upon ax plus b, the integration, now we are going to make the numerator the differentiation of the denominator. So you can see over here that uh, in the denominator we have ax plus b. So if I ask you what is the differentiation of ax plus b, you are going to say a. But a isn't present in the numerator; it's one only. So I'll have to multiply by a constant value. But if I do that, I'll have to take 1 upon a outside as well. Now, if this confirms to a rule that says that if the differentiation of the denominator is present in the numerator, then the integration of such type of functions is simply going to be ln of the denominator, that is ax plus b, and there was 1 upon a outside and plus c as a last step constant of integration. For example, integration of 1 upon 3x plus 5 dx. So differentiation of 3x plus 5 is 3. It's not present in the numerator yet. There is what is present? 1. How can I make it 3? I have to multiply this by 3. If I do that, I'll have to take 1 upon 3 outside as well. Now, now does this conform to a rule?
Yeah, it is.
So if it does, then the integration of such function is going to be ln of the denominator, ln 3x plus 5, and it is going to be multiplied by 1 upon 3. So the final answer is going to be ln 3x plus 5 upon 3 plus c.
Okay.
Let's do this example. Now, if I have a constant number, I can pull it out of the integral sign. So I'm going to be left with 1 upon 2x plus 1 dx. Now for this type of function, the differentiation of 2x plus 1, the denominator is 2. It's not present in the numerator, so you multiply it by 2. If you do that, you have to divide by 2 outside the integral sign as well. Now does this conform to the rule? Yeah? Does this conform to the rule? Hello? Am I audible?